Welcome to Voices Amplified, the podcast for showcasing the depth and breadth of individuals and knowledge within SME's additive manufacturing ecosystem. Find stories of individual people, ones who truly inspire innovation and advancement in manufacturing, and the technology and opportunities AM makes possible. These are people who not only make AM technology a practical success, but also enable it to capture the popular imagination. This podcast is powered by SME, connecting people who are passionate about manufacturing. We hope you enjoyed this conversation, and don't forget to subscribe to keep up with future episodes.
Welcome, everybody. This is John Barnes, and we're on our AMTC Voices Amplified podcast. My name's John Barnes. I'm a past chair of SME's AMTC. I am the president of the Barnes Global Advisors and founder and CEO of Metal Powder Works. I have 2 daughters, a golden retriever, and this amazing podcast. And today we have a really awful dad joke, which is, what's the best way to catch a fish? Ask someone to throw it to you. So there you go. You're welcome. You can use that as many times as you want. So today's guest is a lot like me, a little bit like me. I always wanted to be an aerospace engineer, but decided that material science engineering was my forte. They come to us originally from Illinois, now a resident of San Diego for 14 years. We both have all daughters. They has 3 daughters as opposed to my 2. Also works with their spouse, so we can swap those stories. Also a Lockheed Martin alum. An entrepreneur, member of America Makes Executive Committee, volunteer with SME AMTC, also a member of the Navy League and BattleBots sponsor. Like me, is a DED head and as a vision in hot pink. I would like to welcome Melanie Lang to the podcast. Hello, Melanie.
Good morning. Thanks so much, John.
Hopefully,
I never knew we had so much in common.
Yes, you've probably never seen me in hot pink, but it's
I have not.
It's truly a sight, I'm sure. Well, I appreciate you coming on the podcast. I'm surprised it's taken as long, actually. So I don't recall actually how we first met. It was after you had left Lockheed, but maybe through SME, or was it through Cynthia?
Yeah, I think I met Cynthia first at one of the America Makes events, and I knew who you were, but I don't think I had met you in person ever. And then Cynthia introduced us at the next event that we were at, and the rest is history.
The rest really is history. Well, so I think what I always like to get started with the voyage to additive manufacturing. Did it find you, or did you find it? How did you make the leap from aerospace engineering to additive?
Well, I started investigating additive and what I used to call 3D printing as a hobbyist. So I had my normal job at Lockheed Martin and was chugging away. And, before you have children, you have much more free time. Right. And I started getting into kind of income. Yes, exactly. And I started going to some maker fairs and just investigating 3D printing. And then we built out of a little kit a 3D printer at her house and could essentially print, little gadgets and toys and things. And I just thought it was really amazing what it was doing in the fashion and jewelry kind of industry, and didn't necessarily make a connection to my real job as an aerospace engineer until a couple of years later, when, as you know, one of the biggest challenges with supporting and fielding complex defense systems is on the logistics side, and making sure you can get parts where they're needed, when they're needed, and not have downtime. And as I was going through that process and that thought process, over and over again, I started thinking, hey, I have this little hobby printer at my house that I can print pretty much anything I want out of a polymer material. This is really what the DoD needs to keep their systems, running. And that's when I started thinking about, okay, it's not going to be this little hobbyist printer, but what type of technology would be needed to fulfill that kind of use case? And DED is a great fit because, as you know, you can build parts, you can repair parts, you can enhance parts, and it's a really great tool.
And with that initial printer, what was the most useful thing that you made? So I will tell you that we have an older house, and so it has this French door that used to go out to what they call a sleeping patio back 100 years ago. That patio is no longer there, but the door still is. And we have these fancy blinds that come down, automatically, but they kept running into the door handle. So we designed a little nose for the door handle so that the blinds could slide over top. That's
Oh, that's nice.
Very functional.
Ours was shims, so very, more basic. We were basically printing little blocks, which people still love to print with 3D printers. Everyone wants to go print little blocks and tensile bars, but we were doing that, 15 years ago for our patio table. But yeah, that was probably the most useful thing that we printed with it back then.
I feel like I have a house full that would need a 3D printer just to make shims, because I don't think anything's flat or level at this point. But so, I'm kind of curious to go into just briefly. So you started FormAlloy, and you started that with Jeff, your husband. So how did you go? That's a pretty bold decision to leave. I've always said Lockheed Martin was one of the best places I worked. Phenomenal people, great leadership, etc., and a really good mission on top of it. It has it all. How did you make that difficult decision, or was it a difficult decision?
Yeah, I think it was a difficult decision. Like you said, Lockheed Martin's a great company. I had worked with amazing people, some of the best training I think that you can get, and really what empowered me and taught me what I needed to know to be able to get to this point. I owe a lot of that to Lockheed and the mentors I had there. So it was a very challenging decision. I think at the time it was sort of a good point. I was at a little bit of a transition point in my career, and I had relocated several times. I was being pulled to yet another site to support a different program, and it just kind of worked out. And I was lucky enough where they still needed me to come back occasionally as a consultant, so I was able to, do what I needed to do to get FormAlloy off the ground and also bring in some revenue, because as you know, in a startup, you have to have some cash and way to invest to get going. So I made the leap of faith and was able to do some consulting in case things didn't work out, quite as I wanted them to. And then at some point I just got too busy with FormAlloy, pretty quickly, and that was a good thing.
And so how did you choose DED, and how did that conversation with your husband go? Like, he was like, yeah, I should also go to work with you, or was he doing something similar here,
Yeah, so he has a background in machine design. So he was actually designing other machine tools at the time, and VP of product development. And so he had gotten their engineering department sort of in order. So he's one of these people that if you ask him to design a machine to do anything, he can do it with enough time and money. And so really anything that we would have come up with, he would have been able to find a way to make it happen. But in terms of the technology investigation, we were, of course, we looked at, cold spray at the time. We looked at laser powder bed fusion. And those were really the two, other than DED, that we thought would be viable choices for DoD and aerospace type applications that I was most familiar with.
And what year is this?
This is in the, 2014 kind of time frame.
Okay.
That we started looking at this. And of course, FormAlloy was founded in 2016. That was the year that we brought our very first model to the Rapid show, before it was Rapid and TCT. And but we were working on it, of course, before that time. So in the 2014 timeframe, we started investigating different technologies, and they're all great technologies. They all have a place somewhere in the ecosystem. But in my mind, I thought it has to be a single step to fully dense part, and you have to make sure you have full metallurgical bonding. Essentially, you can't give something to the DoD and have things breaking off of it. And then with powder bed, there were already quite a few players in the powder bed space. And then there's, there are quite a few limitations to that process as well. The size and, of course, repair type applications can be, I know there's some people that are sort of able to do that now, but it's very challenging in powder bed. So to me, that sort of made cold spray and powder bed fusion, not the top choice. And then we started looking at direct energy deposition, and it's like, essentially this technology is based on welding. So this isn't some new, completely new from a physics standpoint, something that you'd be, just inventing this entirely new technology. It's essentially a welding technology that's been around for many decades and in use. And the DoD already has components that have weld repairs, for them. So if we can take a technology that is essentially mature technology already and put some automation and software around it to make sure that it's repeatable and high quality and you can track what you're doing, that's sort of why DED was at the top of our list.
And, I think that's, of course, that was DED's where I started years and years ago. But I think it's interesting. I can't imagine somebody new to it now would be looking into a DED, because I think originally it was laser powder. Then, came other forms of energy, and then came other forms of feedstock, wire, et cetera. But now it's this very diverse space within a, so additive is diverse. You've got the kind of 7 notional families. And within the DED family, you've got everything from, I always lump cold spray into it because it is called directed energy. And if high supersonic gas isn't directed energy, I don't know what is. But you have everything from the material form, powder versus wire, to the energy source, to even the environment. And is it on a robot? Is it on a gantry, et cetera? Anyway, I'm telling you a bunch of stuff you already know. I think it's challenging for people coming into it, though, to kind of appreciate that. And then you have, what we affectionately call large puddle, small puddle, and going back again to welding terminology. Do you sense that people understand the DED space? Is it that, do they appreciate the diversity of it? Do they care? Or do they are just looking for, they come in looking specifically for something? And they're very knowledgeable. All the customers are knowledgeable, of course, but some maybe more so than others.
Yeah, I think we definitely get the full range. So we have some customers and they just want us to make a part. And then we usually start with, what either what your challenges are and or what the requirements are. Why are you asking us to make this part, essentially? Because, of course, at FormAlloy, we do both powder and wire, and we can work with small puddles. So we can work with, about a 0.5 millimeter spot size, all the way up to, I would say, 6 millimeters if you have a big enough laser to get the correct energy density. And then, of course, between powder and wire. So it's always a trade-off of, how quickly do you need to build something? What materials do you want to use? And are they available in either powder and or wire format? And then, what is your surface finish need to be like, or do you care about surface finish? So once we get through those 3 things, then we can help direct them into whether a powder or a wire solution will be a better fit for their application. And then we have other customers that come to us and they're sending us something and they want it made out of wire, and they know the exact material and they know what it needs to cost and the build time and lead time we need to be able to achieve. So it's still a pretty wide range of customer knowledge base that we're dealing with. And, in some ways that kind of makes it fun, because sometimes you're just, printing something or doing feasibility for exactly what the customer wants. And other times you have an opportunity to kind of shape their thought. And it could be that they were, thinking of doing it in wire and machining it in a bunch of way. And then after we take a look at it, we find out that, hey, actually, if we do it with powder, we can get some of those features, in the part, and you're not going to have to do as much post-processing. So it's still a pretty exciting time, and still a time where there can be a lot of learning.
Yeah, and I think that the complexity of making a part versus making a shape, I think this is something that we're increasingly harping on, which is there was a lot of emphasis early on, which really is coming just to being able to make the shape. But at the end of the day, the printer just needs to do its job and make a shape so that you can convert that into a part.
Right.
In a hopefully economical fashion.
Yes. and there can be a huge difference, on cost as you change to different melt pool sizes and different feedstocks. And that's a good thing too, because it's going to open up the space more to customers that maybe are really cost sensitive, but they can accept more of a near net shape, cast like part. And then you're also opening up the space to do things that you can't do with traditional manufacturing with some of the precision powder DED work that we do. So yeah, it's still very exciting. We always talk about in the future, we want to make additive boring, right? We want to make DED boring, meaning it's something that you see every day, because that means it's widely adopted and everyone knows about it and it's less exciting. So I think DED is still exciting and still has a lot to sort of teach and learn in this environment.
Yeah, I think it's the package, it's the programming that's required, it's the interface, it's, all of this stuff has to come together and in some ways it's a curse and a blessing at the same time. The flexibility is also a curse. But once you get that understood, I think it's a blessing in the end, which is, it could be on a robot, it could be on a gantry. I'm sure Jeff is like, yes, we could do both, and you should.
Yes. Yeah. We can do it all.
We can do it all, and twice on Saturday. So, I think the other thing, and maybe at the end of the conversation we'll touch on it, but, like even the scalability and then the multi-material possibility is interesting with DED, especially with the powders and even with the wires. But, we'll talk about the future a little bit. So when you started FormAlloy, and I think right now it's an interesting time. So, we were both at the AM Strategies event in New York, and I think, one of the things I like about that event is there's some technical pieces to it, but it also is this kind of higher level viewpoint. And one of which was the investment going into additive and really what I view as the expectations of the investment. So every year the expectation gets a little bit higher. And I think, expectations are quite high right now that we're actually yielding a return in some meaningful way. So you're 10 years into FormAlloy effectively, maybe not exactly, but close.
Yep.
Is there something that stands out as that you wish you knew, when you started it, or you're better off not knowing and just and just going? I always said, when I started TBGA and then MPW was, boy, there's more questions than I knew that there were answers for. It's just an endless stream of questions came to you. But what was that? What do you wish you knew?
Yeah, I think the first thing is that when you are going to raise money, which most times you will need to do some type of raise, the type of money and the type of investor is really important. And when we were first getting started and I realized we were going to have a need for funds, I had to do quite a bit of research to understand even the different investor types. And that would have been something, it would have been nice to have that in my back pocket. And if I'm ever, crazy enough to do another startup again in the future, it will be nice having that knowledge going in. So that's one thing I would say is, before you, even start writing your pitch deck or, asking different investors for meetings, make sure you really understand the different investor types and what is going to be best for, what you're trying to achieve. And, also knowing that when you take on a round, typically those investors are going to ask for a board seat because they want to have, even if you still are retaining control and majority ownership, they still want to say, and they still are going to want a voting right and to sit into your board meeting. So you have to make sure that the people that you're getting involved with, by name of who's going to sit on your board, and ensure that those people are going to have the skills that, maybe fill a gap for some of the skills that you lack. So, I'll say, very lucky in how our Series A worked out. We worked with a strategic investor that happened to be a customer of ours. We had also a financial investor that was in the mix and potentially going to join, but our customer ultimately, came to me and said that they decided that they wanted to lead the round on their own. And it was a really great decision. Our customer still sits on our board of directors today, and we have I'll say a wonderful relationship, very helpful organization. We've been able to do, a lot of things together. And there's going to be some things, coming out in the future. We'll be able to talk more specifically about, who they are and what we're doing with them. But it really has been a great relationship. And, I'll say part of that was certainly luck. It wasn't because I just happened to know or have the foresight to know that this was going to be a great investor to partner with. But that's the way it turned out. And so hearing other, horror stories and things just made me feel very, lucky that it turned out the way it did. And knowing that if you are starting out, that's something that's really important to understand is the different types of investors and, how they're going to play into what the future is going to hold for your business, if it's going to be more technology focused or if it's going to be more financially focused.
Yeah, I think it seems like, there's a strong desire of younger people to focus on startups, and some of which I understand, some of which I don't. I think part of it is it's not really appreciated how much work it is.
Yeah.
And it requires a skill set that, certainly wasn't in my engineering classes, and that funding piece, and that there are different types of funding interests, out there, and ranging from the angels to private equity to venture capital to strategics, family offices. They all have a different premise and a reason for being. That part has been a learning, as well as the board, and it's all happy days in the beginning, and then sometimes it continues and sometimes it doesn't. I think the quote from one of P.J. O'Rourke's one of my favorite authors, and he has a quote that a little bit of luck and a little bit of government is necessary in life, but only a fool trusts either. So I think it's appropriate here.
I think you're absolutely right. And I'm happy that we went the strategic route, but there's other benefits and challenges with all the different types of investors. So just make sure that you know what you want to do. And then the other thing that kind of goes along with that is you only want to raise money when you need it and how much you need. You don't want to just raise as much money as possible. That's sort of what we did, and it has worked out well, especially if you see what else has been going on, across additive. So always, no matter what, whether you're in additive or really any industry, you don't want to raise more money than you actually need. One, you're going to reduce your own equity share if you do that. Two, typically if you're raising more money, your valuation is higher, and that's great. But as you continue on, if you're not able to achieve the financial metrics of the company, you're going to be devalued and you're going to lose, even more equity. So yeah, just food for thought. And I guess the last thing of that is if you raise more money than you need, there's probably going to be some money wasted as well. Because you're going to have all this money to spend, and you're going to feel inclined to probably spend it on maybe a larger booth than you need at trade shows, or, a really, fancy facility. I know the first couple years we were in existence, we were working off of card tables and folding chairs. That was our desks and our conference tables. And I remember bringing investors through and apologizing. I had thought about even trying to rent furniture to kind of impress these investors that were coming through. And when they saw I'm using quotes with my hands right now, office, because it wasn't really an office, it was just a space that I had a card table set up in. And I said, hey, my apologies, we haven't gotten any furniture yet, have a seat at this folding chair. Afterwards, one of them kind of pulled me aside and said, hey, don't worry about the furniture. We were actually pleasantly surprised and happy when we came in and saw, hey, this company has been here for, almost 2 years, and they're still working off of card tables and folding chairs. And that means you're spending your money probably wisely on things like developing technology or even patents, right? Because those are also very costly. So if you don't have the money, you're not going to spend it. And if you only have a little bit, you're going to spend frugally. And, thankfully we have proper conference tables and desks and chairs for all of our dedicated teammates today, but we're also in a place where we can do that, and we should have that.
Yeah, it's well, first is I think having a view of what the medium to long term looks like. So different founders will have a different probably perspective on things, but I think there is no such thing as a free lunch. You don't get something for nothing. Whatever your cliche is, still fundamentally true. Don't take on, more water than you can carry. And so with that, I guess there's a lot of concepts in what you just said, valuations, having board members, and even kind of digging into what is the role of the board. And that seems to get off track occasionally as well, mostly because people are interested, it's not nefarious. So this funding process is a learned skill. We don't get it in school, at least I didn't. And I think a lot of times you have to have a pretty good idea of what you're going to do. You have to go find somebody who's willing to nurture that with money. And then eventually the most goals for people is to either run this as a going concern or they're going to exit through a sale. And, if you think about the prospect of doing that, having a good idea is, it's a challenge. Getting other people to agree that it's a challenge to the point where they're going to give you their hard-earned cash is an achievement. And then you get to a point of saying, somebody says, yeah, I'd like to write a check for what you've been doing. I mean, these are all pretty amazing things to get accomplished in one's life. So having that knowledge about what it is that you want, what is there one thing in there that is a more desirable than the others, and then figuring out how that funding goes. So, and then, and I think too, you touched on the evaluation, and I think this is we're at an interesting point in time. We've seen some pretty phenomenal valuations, and maybe for that listener at home that doesn't understand evaluation, it's, you said that you can be worth so much money, this idea or this concept, and the challenge for most startups or something that's in a startup phase, they might have some revenue, but maybe they're not profitable. So, traditionally there's if you're going to sell U.S. Steel, for example, to Nippon, which is in the headlines, well, U.S. Steel has profitability, it has a valuation, it's relatively easy to say it's at least worth this much. Now, how much more you're willing to pay then goes into a category called goodwill, and then that eventually has to be made up. Otherwise, the customer overpaid for it. That valuation thing was a topic of conversation at AM Strategies. What was kind of interesting outcome of that for you, and your perspective as the lean and mean startup?
Yeah, I mean, I think, valuations went a little crazy for a while, and I think the pendulum is swinging the other direction. When I say a little crazy, I think a lot of valuations were overvalued. So people were overpaying, and they were willing to do it. There was a lot of hype associated with, the whole additive industry. Now that has subsided some, and I think some of it has been because the industry hasn't taken off as much as, it was supposed to. When these outlooks were made and people were talking about this, 5 or even 10 years ago about how big the industry was going to be in, 2024 and 2025. I don't think that we've realized that. I think that we will get there. I just think it's moving more slowly than, I guess, industry experts expected. And a lot of investors were willing to, buy into the potential to have this, just absolutely huge, industry that was going to just, change the course of history, right? And now I think they're, coming back more to earth. They're becoming more realistic. I think even the pendulum has swung a little bit, maybe too far, one direction, but there's a lot of other things going on with the economy and things that are, money's expensive now. And, I just think there's not as much investment or M&A activity, going on now, but I think it'll sort of level set itself. It'll right size itself where valuations will be good for founders and investors. And there'll be, money to continue to fund, these type of activities, and there will be returns. It just might not be as aggressive as, people were claiming that they were 5 years ago. So I'm excited. I'm still hopeful for where the industry is going, not only from a technical standpoint, but from an economic standpoint and consolidation standpoint and all that. I still think it's a great industry to be in. There's still a ton of opportunities, whether you're a founder or an investor. We're just going through a kind of a resizing and, coming back to earth, I guess, is the best way to describe it.
Yeah, well, money tends to sharpen the focus a lot. And I think that we had a external activity come in and interest rates were higher, so that meant that money earns money in the bank.
Yep.
So now you're competing with a known as opposed to perhaps a greater unknown. So that's a usual thing, and so that, additive didn't have anything to do with that. It was an external factor that came. And I agree. I think that it's the evaluations got away a little bit. They're come back, and I'm still bullish on additive. It still solves a lot of problems across the board. You look at all the challenges that we have around, we've got this record low unemployment. Yeah, so everybody that wants a job has one, and yet we still can't find people to go work in foundries and in manufacturing and, these things. But I think where I've seen is that people are willing to go work in an additive manufacturing facility. It's safe, it's clean, relatively speaking. So I share your enthusiasm, and I think that, as you said, too much money isn't a good thing either. You start focusing on, things. So in Australia, we had the term, cashed up. So cashed up was just a great way of saying you were going to blow some money on some things you didn't need. You need to have that visibility about what it is that you're going to do. And, like gambling, the house always wins. So, the people with the money tend to know how they got the money in the first place. So with this, we touched on the market consolidation. And so, I think my view, and I'll just give you my opinion, and then you can agree or disagree with it or add to it. I think what I heard again at the AM Strategies was there may be too many printers, specifically in the powder bed space. I think it's probably too grandiose to smear that topic across all of the different forms of additive, because I don't think that's true. But we have printers, we have materials, we have part manufacturers, and anecdotally, it seems to me like the part manufacturers are doing better than they were last year, and the powder manufacturers are doing well. So the powder has to go somewhere. It's clearly going to make parts. With all that as a preamble, when you hear about market consolidation, like it's an easy term to throw out there, and it sounds really, intelligent. But what do we mean when we talk about market consolidation from your vantage point?
Yeah, I think it is, it's sort of the M&A type of activities or strategic partnerships that are going to take all these, smaller entities and sort of form them into larger organizations, or, absorb them into existing, more mature companies. And I think in general, that's a good thing for most industries because it's a sign of maturity. It's a sign that, investors and other companies and entities believe in it enough to, turn it into something bigger or combine it with something that's more traditional, that's been around for a long time. And you're not going to get that happening when the tech is still new and unproven, because, no one's going to want to spend the money to do that. So I think it's a good thing, and I think it's a sign of maturity. And I think, when that starts to happen, there's going to be winners, and then there's going to be, companies that don't make it, through this time when there's not as much money in investments and valuations are a little lower and it's harder to get funding. So you're either going to be, part of the consolidation in a good or a bad way, or you're going to continue to, thrive on your own and make it through. And, I'm excited to see what the next couple of years hold, because I think, for those of us that are doing real things and have been doing real things for a long time, and not just talking about it or having good marketing, but actually, doing things and creating end use parts and all that, I think it's going to be really exciting to see what happens.
So yeah, you're definitely not so much in the woe is me state as you are, this is a maturity sign. This is a good thing, even if it's a little bit painful.
Right.
No pain,
Absolutely.
no gain. Yeah. And I think, personally, I always say, we're always going to be here. This is a necessary portion of growth. and a little bit, the consolidation is one word for it, but it means if somebody's willing to buy your company, going back to, as a founder, hey, if you manage to make it through that's a phenomenal success that most people will never experience. You've created something,
absolutely.
You got it to a point, and somebody's willing to pay for it.
Yep.
So that then begs the question, where are we going? What's your crystal ball look like these days?
Well, my crystal ball, has always been telling me the same thing, which is why I got into direct energy deposition to start with. And that is that the DED technology is, the way of the future. I think a lot of the applications have been proven out with other technologies like laser powder bed fusion. And, people have gotten very comfortable with that technology, but now they want to go faster, cheaper, and potentially bigger. And when they want to do that, they may need another technology like DED, which can accommodate, higher throughput, typically larger builds, and, typically more affordably as well, especially as you get into the wire feedstocks. So I think it's, a great way to, take what's been done and set, keep that foundation and sort of keep it going. And I don't want to make it sound like DED is going to, take over for other technologies. I think it's just going to expand the use cases and expand the customers that can get into it. I think one of the early adopters of additive is, of course, in the, aerospace and, government work, whether it be, research and grant kind of funding or, actual programs. And I think as it becomes more adopted and more affordable, it's going to be expanding. And, we're already seeing that even in DED and, even the commercial goods sectors, general industry, people that can't just go invest millions in dollars just to test a technology like they can in some of the other industries. So I'm really excited to see what DED can do. And I think, right now it's, we're really focused on, casting and forging replacement and repairs. So when customers can't get parts and they need it, especially, you see what's going on with the DoD right now, and they're doing a lot of investment for companies for the submarine and defense industrial base, because they need parts and they need to continue to support our military, and it's hard to get all the parts to do that. So I think that's sort of a current reality that we're able to support really well with the direct energy deposition technology. And then, similarly on the repair side, we can, repair parts, whether it be an existing part that's approved for a weld repair or a part that currently doesn't have a repair process. We can do that. And then I think in the future, what will keep, that stuff will hopefully get boring, really soon. We're making end use parts with DED, and, everyone kind of sees it and it's, widely accepted. And then for the future, I think what will keep DED exciting is all this multi-material work and custom alloy development. That's one of the really interesting things that is fairly unique to direct energy deposition, just by the nature of you're placing material where you want it, and you can change that material and place it in different areas of the part. And that's something that we've been doing at FormAlloy for a number of years, and we have a really exciting project going on with DARPA where we're looking at material on a continuum. So you no longer need to think about material on a discrete basis, but rather what areas of your part need to perform in a certain way, and then you sort of back into that material solution and depositing, the exact material that you need. If you think about it as a turbine blade, for example, you might need, high hardness or high wear resistance, good fatigue life in another part of the turbine blade, right? And right now you have to pick one material that can do all those things. Right. So what if you can have a, functionally graded or continuously changing material that's going to give you the exact performance where you need it on that part? And I think that's part of the future of, what DED will bring to the market.
Yeah, that's where the domain expertise helps out. So, I always, like to tell, especially with my daughter being at school now, I lectured at one of the MSE courses, and I said, know your technical discipline really, really well. Most of advanced manufacturing is teamed, though. It's no longer somebody just working alone. And additive is a very team sport. There's metallurgy, there's optics, there's structures, there's dynamics, all this design. And my advice to the students was you've got to be able to communicate. And if you struggle with that, which is fair, there's a way to deal with that too, which is make a friend or, deal with people that you can work with to help communicate these ideas and these concepts. Because in the sense of a submarine, that's a very demanding environment, and the qualification of that is not going to be easy, and it must be done. And in the one sense, we're dealing with maybe a casting, and that has, it's an older technology. So, I think the data that's available to us is significantly higher in the castings than it is, in the DED or any additive technology. Accessing it, making something useful of it, well, that's a bit of a challenge. In some cases, you can get too much data, and what do we do with it? But I think I've probably told you this story before. I remember dealing with my Air Force customer, in the early 2000s, and I said, gosh, if somebody were to come from Mars and we were to show them two ways of making a part, one is let's pour some liquid metal into this, shape. And the other was, something that looks like additive and all of the data that we can capture. I fail to understand, and this is not a slight towards casting. It has its place, especially when you're talking about single crystal blades, and that is going to technically be better than what you can do with additive, at least today. But it clearly has a space too, and so that, again, the economics comes into it. And I know you're a big advocate of the smarts that come with the DED piece. What are we able to capture in that? While we're making a part with the DED process, how much better off am I with than I would be through some traditional process?
Yeah. Thanks for bringing that up, because I think data is obviously extremely important in your part for repeatability, and so that way the quality of the part. And we're able to capture really all the information that you need to assess if your part will perform the same as the previous versions of that part. So we're looking at all the different machine elements and data, and then also able to sense different aspects of the melt pool, including the size and the shape and the temperature. And when you do that, you can really get a solid understanding of if your part is being made the same way, or if there's any anomalies in that part data that would lead you to believe that you could potentially have a failure or some type of defect. And to this point, qualification has been done typically by building many material samples and tensile data and getting statistically significant amounts of data, so that way you have confidence in your process. But even if you do that, you may have you may test 1,000 parts, and you may have some type of defect in the 1,000th and first part, right? And you don't know, it's an anomaly, just like you get in castings, you get defects, right? And you don't know necessarily when or where, and you get some process variation. But if you're able to use all of this data, this machine data and the melt pool data, and analyze that data, you have much better insight into your part and into any anomalous behavior than you would with any traditional manufacturing process. And, that's something that I think should give, end users and, anyone who works on qualification just a really good sense of, comfort, knowing that if you can have a data set and you know what a good data set looks like, it's very simple to look for variations in that. And I think along with that, sometimes you can get a little bit, too caught up to your point of having too much data, where instead of saying, hey, we have all the data that supports knowing that this part is good in terms of being defect free and then also performing however it's intended to perform. So if you can build the part the same way, and you can show that there's no, variation beyond the limits that you've defined, then that could be an acceptable way to say, yes, we can get through qualification of this process. But sometimes what we're doing now is we're trying to define what all the corner cases are that would still be good enough to qualify. And when, I get into conversations about this with customers but do we really need to do that? I understand that there's corner cases in which the part could still be accepted, but we don't necessarily need to start out defining all of those corner cases. If you know that a part is good and it performs the way you want it and it's defect-free, then that's what we should be trying to base our future off of, right? And over time, you can develop these larger databases that said, well, we printed this part that, the laser power, the melt pool size was way off, but it still performed. Okay, that's great. And then in the future, you can maybe loosen up your bounds, or you can, figure out what was going on in that corner case that made it perform. But you don't necessarily need to collect all that data to start, just get a part that's good, understand the data that's associated with that part. If you build, 10 parts and one of them has anomalous behavior, then take that one and do extra testing on it, or, CT scan it, or whatever your testing plan might be. But don't get too caught up in just trying to collect, ad nauseum amounts of data to define every single corner case. So hopefully that makes sense. But yeah, you use data to your advantage, not to your disadvantage.
Yeah, it always strikes me on that Donald Rumsfeld quote, which is, an entirely different situation, but there's known knowns and there's unknown unknowns. And it seems like we're perpetually focused on the known knowns, which are still better than legacy processes. We still know more about them than we did previously. And sometimes that new data is scary just because we don't know, but it clearly, kind of worked. And I think too, an earlier guest that we had was Paul Gradle from NASA. And, we talked about this need for, it's a repeatable, reliable process. We're not asking for perfection. Perfection is not the goal. It is, I just need predictability. So if you're saying that in this window or with these known conditions, my part performs as it needs to, then, really that is the goal
that's all
of
you
the
need.
qualification. Yeah, that's the goal.
Yep.
It's not being perfect. Well, we're at the most frightening point of the podcast where, you get to ask me questions if you have any, or what's on your mind. So any questions that you have for me?
Yeah, I mean, I guess, where do you see all of this, additive stuff going? Do you still see a lot of potential for growth and new applications, or, I have my views. Obviously, I have, one technology that I love and live and breathe every day. What are your thoughts, I guess, in general, where you see things going?
I'm still optimistic. I think that we see applications every day that most people are never going to hear about. And that's also that sign of maturity, which is we're not talking about every application. It's not interesting anymore. And, when you have, I always find it remarkable when we have companies like in heavy transportation making use of additive. That's a pretty remarkable thing, because that's more about, the lightweight doesn't really matter. It's mostly cost. And it's really puts more emphasis on the design. And so we're also seeing more engineers know enough about the process to squeeze out a design that looks capable. The design in general, I think there's still a huge curve in front of us in terms of getting people familiar with how to design for this process versus prior ones, because it still is significantly different. Even in the case you were just talking about, like in a forging, we have a forging shape and there's flash material left over, and we exercise parts and tensile coupons from that. In additive, you have to pay for the parts that you want to be tested because they're not there otherwise. Yep. So it's a different way of thinking about it. And I think that the combination of the technology piece, and I've always, I've worked around smarter people than me my entire career, and really trying to nail down, well, we can do something. And the question is, should we do something with it? Mm-hmm. And I think additives scratches that itch. We can do a lot of things, but what do we really need to do? And that's where the money piece comes in and tends to sharpen that focus a little bit. So I think as more people get into it, I think that the need overall, especially for this country or any Western culture, the automation brings a skill set versus relying on skill over automation. And I think, we're kind of seeing that with some of the casting. The high mix, low volume is hard to deal with for that industry. And those of us that have dealt with DoD, that's really all that industry is high mix, low volume, especially and dealing with continual obsolescence. So I don't buy into the pessimism or that 3D printing's dead, or, and if it is, like Tim and I always say, well, long live additive manufacturing. So let's just move on to the manufacturing piece and worry less about the shape creation piece. And we still have other technologies coming along. And I think what's also interesting is every month or so, you read about some group of engineers that has been working in one area and had an idea, and they're making, their own version of it. And so this continual path of innovation, and the whole country was built on creative destruction. So additive is no different. In some cases, the speed of it is mostly the problem. We're creatively destroying things too fast, allowing people to catch up. So yeah, optimism is still warranted. Perhaps it's cautious optimism, and kind of goes back to what we were talking about originally, and the valuations and the money and who's paying for this and the expectations. It always comes back to shaping the expectation of the customer, expectation of the investor, expectation of the founder, and creating that trifecta is a little bit magical in some ways. But when people are willing to be rational and accommodating, and they realize that, hey, maybe John gets 80% of what he wants and Melanie gets 80% of what they want if we work together, versus we could have 100% of zero.
Yep.
Well, all right. I really appreciate that you took the time this morning, and I think this has been a very useful conversation, especially for those prospective founders out there. And I thank you for coming on the show and continuing to do all the stuff that you do for the industry. I think that it goes unnoticed a lot of times, but I've always found that people do notice, they just don't say anything about it. So anyway, appreciate you volunteering with America Makes and the Navy League and BattleBots, and trying to encourage more people to get into our space, because the brains are what's important. The shape that they come in is probably a little bit less important.
Absolutely. Thanks so much for having me, John.
Behind the novel machinery, materials, and finished products are specific individual human beings. We are proud to share their stories. Thank you for listening. We hope you enjoyed the Voices Amplified episode from SME and will join us for future installments. If you like what you heard and want to support the show, you can do so by sharing the show and by heading over to Apple Podcasts or wherever you listen to write a review and subscribe to keep up with future episodes. Don't forget, you can join the conversation and learn more at sme.org.